Hello, I want to do some game development, and for this I'll need to make some tools. I'll first start by making a tile map editor. Tile maps usually make up the level in 2D games where the art is created from a collection of tiles. Some famous examples of games that use tile maps are the first Duke Nukem, spelled with two U's in this case, Ultima, and a Kolobev spin-off, and the Elf and Plumber game from that fucking Japanese company that sues all of its fans. Doom Guy and code dude John Carmack recently did an interview with Lex Fridman where he mentioned using the same tilemap editor from the Catacomb days all the way through to the Wolfenstein 3D era. On a side note, I need to mention that a two-dimensional tile-based level can easily be translated into a 3D one using raycasting, which is what they did back in the day. So the program that we'll be ripping off today is called Nmap. Not the security scanner, but the original Wolfenstein 3D map editor. Nmap was originally written for DOS, but I'll be using a Windows environment to develop it. Since I don't want to see ads in my start menu, use Microsoft Edge or pay for Windows. I'll be using its less bloated counterpart and future successor, Windows PE, which stands for Windows Pre-Execution Environment. WinPE is like DOS without all the fuckery of legacy hardware and some rudimentary GUI, which isn't full of spyware. This is what peak performance looks like. After having spent a considerable amount of time not only getting the Windows Advanced Driver Toolkit and its plugins installed, with quotation marks, on my GNU Linux-based system, I also had to spend a considerable amount of time tracking down a 32-bit supported version of the toolkit, since in the latest version of the toolkit, the 32-bit support has been removed. I will be containing Windows PE in a VM or virtual machine, so that I can nuke it at the end of this project, and continue my ascension to a higher plane of existence with the continued adoption of this GNU Linux system. On another side note regarding 32-bit support, while I am aware it is being phased out in the majority of new modern operating systems, my practice in the past has always been to produce two versions for each platform, one for the 32-bit platform and one for the 64-bit platform. As forward porting is usually a simpler process than backporting, for example, changing a few parameters in the command line. In the past, I will usually start with a 32-bit version of an application and then go from there. I will mention that potentially a native 64-bit Linux version of this application will potentially be produced in the near future, once I've gotten my head around the NetWide Assembler or NASM SDK. There are a few things we need to do to set up our dev environment. The first thing that we need to do is set up a Git repository so all our code can be securely backed up, because if you don't do this, you fail as both a programmer and a human being. On the target VM, we will need to set up Git, so download it from the git-scm.com website. Go with the portable thumb drive edition. There is no web browser in Windows PE, so we will need to use a PowerShell command to download these files off the internet. Do you see, Microsoft? There is no way Edge can be considered a critical component of the operating system, and anyone who tells you that it is a fucking liar. Once downloaded and installed, git init and git clone the repo. We will need a compiler, so download the Masm32 SDK from masm32.com. This is all of the development software that we will need, trust me. The website is even amongst the stars as we are ascending to a higher plane of existence. I am also a liar. We will need to download Notepad++ to help us with our development and to provide syntax highlighting and tabs. We should probably make sure our compiler installs first, so let's run it. Use the installs default directory unless you are a masochist. I usually create a folder in my repos called tools. This is where I extract all my dev tools to. For this we will need to use a PowerShell command called expand archive. I'll then make a .gitignore file so I don't clog up my repo. The only downside to this is if I move computers or if I need to rebuild this VM, these files will need to be re-downloaded. Metaverse Conscript and Cyberdemon John Carmack encourages developers to take steps to archive the development environment so that you can be confident that you can rebuild things years into the future. Since we have essentially introduced build dependencies into our dev environment, it's a good idea to write a dev environment setup script. Basically copying down all the commands we just run into a batch script so that we can run them again in the future. I even go to the extent of ensuring I know what version of a program or SDK I've downloaded. And if that SDK is no longer available from the vendor's website, I will include special cases in my script to acquire it from the Internet Archive instead. When using any version of Windows PE, it's important to always commit your changes to disk, or do a git commit. You could always save the state of the virtual machine and reopen it later on another machine. This is what I had to do when I left for work this week. Here I am rewriting the script in Notepad++, because like a moron I didn't do any of that. With the dev environment setup script written, there's not much more setup that needs to be done. So I will rclone in some tunes from my Plex server, so that this video can be DMCA'd. and so people can secretly try and work out my age from the grungy trash that I listen to. I later realised that this was pointless since I never set up sound on the VM, and I can just listen to music on my host machine, although it would have been cool to see Winamp running again while in the background while I coded, with quotation marks. So I ended up rebooting the VM. This gave me a chance to test a setup script. It works great, although it can do with some improvements, and I realised I had to change some lines before I reran it, and there are still too many manual clicks involved. Now with our dev environment set up, cd into the MASM32 directory. This is Pro writing a tilemap editor in assembly, so we're going to use Pro Tools. Go ahead and fire up prostart.exe. It's interesting to see how dingbats were used for the toolbar button layout. Make a note of how it doesn't render properly in Windows PE. That's foreshadowing. Prostart.exe is in fact deprecated, so forget anything I just said about it and start up an application called cg.exe. Delete any files in your repository if you've made them. It's at this point in the video that I should mention, due to my poor planning, this isn't really a video tutorial, per se. Probably more of a development log as I didn't have the foresight to plan this project properly. Soon you will see what I mean. After running cg.exe, you should be left with a few files in your repository. That's assuming you set the target directory correctly. I did, but for whatever reason it dumped it in the compiler's directory, so I simply copied and pasted these files over to my repository before committing them. I put these files in a folder called src, which is short for source. Now if we recompile the project by running makeit.bat, it should build without issue. If you get an error like the system can't find the path specified, that means you need to modify the build script. In this case it built without issue, but given some of the fuckery I've had in the past with MASM32 and environment variables, I'm going to tweak the project's build script and add my own special source to it. The lines I'm adding to the script now will make it easier for Windows to locate the compiler. This fixes a dumb issue I have on my work computer where the compiler is installed to a different drive to where my projects are stored. As far as I am aware, this is the easiest way to overcome this issue. This harkens back to earlier on in the video where I advised to install the compiler to the root directory, unless you were a masochist and you enjoy pain and suffering. The modifications that I am making to this script are based on a template that I have on my GitHub gist. This is the part in the video in which I talk about my obsession with programmatically drawn graphics. At least that's what my obsession is for this week. Next week? Who knows? I don't consider myself a software developer, more of a problem solver, and since I ran the template generator for this project, I've been obsessed looking at the toolbar images that are generated. WinPE doesn't have MS Paint, and there's no way Adobe bloatware Photoshop would work on this VM. I could potentially use GIMP, but again, I'm obsessed with programmatically drawn graphics from the command line this week, so I did have to do a bit of research and some thinking. Wingdings, that shitty symbol font. What if I could just extract symbols out of that and use them to draw the graphics for my toolbar? It's probably a good starting point to think about what symbols we would actually need to define the functions in our program. And this is where I will admit that I hadn't quite planned this project properly, so I sat down and made a list. One important function the program will need to be able to do is to open a file, so an open or load button is needed. This is usually represented with a folder icon. If we have the ability to load, we want to have the ability to save, so saving to disk is represented by a floppy disk. Or a 3D printed save icon if you're a fucking zoomer! Looking at the MS Paint interface for inspiration, undo and redo look important. So does clipboard functionality. Cut, copy and paste. And a find and replace function may prove useful. Finally, I want the ability to export, whether it is to a text file or to a flat image. I'll figure that out later. Fortunately, Windows includes a tool since Windows 95 that allows us to view all the character symbols in a given font. This program is called character map, or charmap.exe, or %window%system32 \charmap.exe. This program is not present in Windows PE. Fuck! So I did the next best thing, and I went and obtained a totally legitimate copy of it off the Internet Archive. Despite this being the part of my day where I have access to a fully working, fully functional version of the Windows operating system, I still continued to use the VM. I ended up downloading 7-zip to extract some of the files from their installation sources. This might be an important tool later, so I will add it to the setup script. There was a bit of back and forth trying to find the right version of charmap that would work on this version of WinPE. Eventually I got it to work after some dependency troubleshooting. And then the next problem presented itself. WinPE is a cut-down version of the operating system, so it doesn't come with wingdings. That's why the font didn't render properly earlier in both ProStart and CG.exe. Not to worry, the Internet Archive's got your back. I downloaded them directly into the fonts folder and hope for the best. After downloading the new fonts, I had to register them into the system using the reg command. Normally you would just right click on the file and select install to install the font in Windows, but this meant that the process could be automated in the setup script. Finally, after about an hour or so of piss-farting around, I came up with this list of symbols that I want, what functionality they would represent, what character code they were defined as in the character map, and what font that symbol belonged to. For some symbols that don't necessarily have something to represent them, I have planned to combine multiple symbols to achieve this effect. This has also made my table a little bit complicated. So I merged the character code and font cells together. And from there, I was able to add more complicated symbols that I was going to create using a comma as a delimiter to separate each symbol. The order in which they have been placed is the order in which they will be rendered, with the first graphic being the bottom layer. And then I used this ASCII code chart that I have on my website to convert the hexadecimal value used in the character map program to the actual symbol on my keyboard. A simpler way to do this would have been to open up Microsoft Word, or whatever the equivalent is on Linux, and just type these symbols into a document, and then convert them to wingdings, and then convert them back again to a normal font, once I picked the characters that I wanted. But I like to be very elaborate with this kind of stuff sometimes. So on my crappy GitHub website, all these images are rendered using a program called ImageMagick. This is where I will confess that I started the process of pragmatic image creation a few months ago when I was trying to create my own version of SpeedTree, but two-dimensional version for two-dimensional games, and games that still use sprites. It's an aesthetic choice. Using the PowerShell command, I downloaded ImageMagick Portable and extracted it to my tools folder. I also took this time to update the dev environment setup script, as well as adding those missing fonts. With the new changes that I've made to the dev environment setup script, it can now automatically install Git in the MASM32 compiler without the need for me to click on any of the dialog buttons. This is what is referred to as an automated deployment process, and it's common in the industry for things like Docker or for DevOps teams to implement, so I normally do this out of habit. I added this dialog because this part of the video is very quiet. There is actually a rudimentary image viewer inside the MASM32 SDK, at least for bitmap images, which is what Win32 applications usually use. It's found under MASM32 examples, example 01, show dib or dib, and the executable is called showdib2.exe. With this I was able to figure out the resource files that were created when we ran cg.exe that created the project template. I then started writing a new script called maketoolbaricons.bat. I updated the blue gradient file, bluegrade.bmp, to match the gradient style used on my website. And the next part was just trial and error until I was able to get all the image icons into a nice enough state. Every time I would make a change in the script, I would rerun it and then recompile the application to confirm that it was rendering properly. This was very tedious, but also a lot of fun. I'm going to try and speed things up for this part of the video, because you're probably sick of old man types at terminal, so I'll just cover the mistakes and fuck-ups. The gradient file was actually left behind in the MASM32 directory, which is why the program's still built. I forgot to copy it into the repository after running the CG program. This was a pain in the ass, to say the least. I initially had trouble trying to figure out why some of the symbols wouldn't draw. Turns out I simply misspelled wingding as wingdings, but I learned a new ImageMagick command, -listfont, and discovered some more misconfigurations with WinPE. The background gradient, once generated initially, would cause the project not to build. This was down to the BMP file version that was being used. The fix was to specify BMP version 3 in the command line. This git commit in particular was conducted in the ImageMagick tools folder, which ignores my .git ignore file. So I ended up doing a git reset and rebooting the VM. Fortunately, I was able to pull down the setup script and rebuild the development environment pretty quickly. Another developer heard my screaming and came to my aid, and they were horrified to see what I was doing with a bare bones cut down version of the Windows operating system. Notepad is the shell became the meme. Both running the program build script and accidentally committing the ImageMagick folder to the repo caused the system to run out of memory. The ImageMagick folder caused the system to run out of memory because Git had to cache the changes, and every time I reran the application's build script, it would run the resource compiler. And since I was creating the image files with ImageMagick, they didn't always comply with a format that was compatible with the resource compiler. And when the resource compiler failed, it would leave behind unusable object files. But these didn't have the correct file extension. Instead, they started with an RC, followed by a random string of characters. Doing this about 100 200 times in an hour generated enough data for the system to run out of memory. And the result of the system running out of memory meant that any command that we ran on the git shell would return an unexpected or random result, meaning that their attempt to resolve it proved futile. I did have to pay the other developer off with the chai latte though, so they were happy with their efforts. Eventually I was back to working on the toolbar icon script. If you look at my script, you will see that I'm now using a new tool, InFramView. This is because when I started generating icons for the toolbar, I had trouble converting them to a format that the MASM32 resource compiler would recognize. I spent a bit of time trying to get ImageMagick as well as a variety of tools to convert into a supported format until I found InFramView. I downloaded InFramView Portable using a PowerShell command and added it to my tools folder, and later the dev environment setup script. It's a good thing we downloaded 7-zip earlier, as I needed to use that to extract the installer. Once I had completed this, I was able to export the bitmap file to a 256 bitmap that the MASM32 resource compiler supported. This also fixed the bitmap transparency issue. Some other hacks. The Wingdings font didn't have a sufficient magnifying glass that I liked, so I cheated and used a crayon and a circle joined together to form the magnifying glass. I also did a similar thing for the export icon. I took the new file icon and I then added a red arrow to it. I also took this opportunity to start making the applications icon. I also added a bit of color to the toolbar. It looks good enough for now, but I'll come back to it later. Next, it came time to figure out how I was going to draw and store the map tile icons. When you think about it, all a tile map editor is just a fancy line editor. In fact, I think the original Duke Nukem map editor is composed of a text mode editor, with the object and map entities being represented by ASCII characters. Nmap for Wolf 3D was a little bit more fancier, as it implemented mouse movement and allowed for the characters to be redefined using 8x8 pixels. I wanted this application to be reusable for other projects in the future, but for now all I needed was 8x8 icons, similar to how the tiles were represented in Nmap. I also knew that I wanted to make my tile set incredibly compressed, so I stuck to only using 16 colors using a color palette. I defined a color palette using a HTML file and HTML colors because it seemed to be the most easiest way to visualize what I was doing. In the VM, I was originally going to use Microsoft Paint, but I know this version of Windows doesn't come with it. I could probably download it like I did with CharMap off the Internet Archive, but that sounds like a video for another day. So I dug through the MASM32 SDK and came across MASM32 /bin/image edit. This is the resource editor for MASM32, and what I probably should have been using for drawing my toolbar icons, but like a fuckwit, I used ImageMagick and the command line. I knew I was going to have about 256 icons, so I started with a 512 by 512 bitmap, but ImageEdit rejected the size, so I went with 4 256 by 256 pixel wide bitmaps. I then came up to a visual zoom limitation of the program, so I scrapped this in favor of individually drawn icons on an 8x8 square. I imported my custom palette into the image edit application. This was essentially converting the hexadecimal values to decimal, and then setting the custom colors in the dialog box. There is probably an easier way to do this, but I don't care. In the res folder, I made a new subfolder called tiles. I started with the naming convention of tile000.bitmap. There are actually two modes that the game that I am working on has. One is the world overview. I may use another tile set for this, and the other is a dungeon room view, similar to the block-based rooms that are represented in Nmap and Wolf 3D, except I am not using raycasting for this project, but I'll get into that another time. So, for the dungeon and room, I broke the tile set up into distinct blocks, with each block being stored on its own plane. Walls are 0 to 50, floors 51 to 100, objects 101 to 150, entities 151 to 200. For example, a floor or a wall tile can either have an object or an entity on top of it. Since bitmaps are composed of binary text, the next problem to solve is compression. How are we going to take these binary files and convert them into low-level text for our program to parse? Since I am only using 16 colors, we can use hexadecimal notation to represent these colors, 1 to 9, A to F. If I use every letter in the alphabet, in the future I can have up to 32 colors, assuming I only use capitalized letters, or one case set. Sidestepping here for a second, I did some cute little pixel art in this part of the video. Can you tell that this is a sword or a chicken drumstick? Later I did another git commit. Okay, so now how to extract that data from the file without manually writing out the value of each pixel by hand. We can ask ImageMagick, nicely, to enumerate each pixel as a HTML hexadecimal color value for each tile. This gives us a text file for each tiled bitmap file that we can process further. So I started work on a new script to do the processing. That's what I would say if it wasn't for the fact that I noticed a bug in the text file output. Those are not the colors that I specified in the color palette. So the bug had something to do with my custom color palette. I probably should have used the default, but I set my color palette before deciding that I would use the image edit program. So now what transpires is some further troubleshooting that could have been completely avoided with a simple command, but you'll see that at the end. I ended up simply converting these bitmap images to bitmap version 3, which also further compressed them. Now you'll see me writing code in PowerShell after I did a hex dump of the color palettes in the image edit program. This was to get an idea of how they were stored, but I also didn't want to go through the process of setting up my custom color palette in the app because the UI is a little bit awful. Instead, I ended up downloading an old friend, XVI32 or 1632, but it's written in Roman numerals, so I'm going to refer to it as XVI32 just to upset people, which is a pretty decent hex editor written in Delphi, and one day I should probably make my own, but I'll use this for now. I am certain that if I actually went out of my way to find out, someone could tell me why I tell PowerShell to output a simple hexadecimal character. For example, FF. Why the fuck does it become 3F? It's probably an encoding problem, or maybe to do with how my hexadecimal notation is formatted. Fuck knows. I could post a question on Stack Overflow about it, but fuck those guys. So I ended up editing the palette file with XVI32, real hacker man like. I need to interject some commentary into this video here, because holy shit there's a lot of footage. You may have seen me earlier in this clip exporting 3 distinct versions of the color palette. One a default palette when the program is loaded, another completely black, another completely white. This was purely so I could figure out the binary structure of the files without any documentation. Eventually, I came to the realization that what I was trying to do isn't fixable by recreating or loading the original color palette, so I started looking for an ImageMagick command to fix this issue with the files. ImageMagick is a good app, but its documentation fucking sucks. I found a command to change the color value in the file to the correct color value that I wanted, as well as at the same time converting it to a bitmap version 3, which resolved the problem. Or at least I thought it would. I later found out that there were some files that running this command didn't affect, and since I'm not 100% sure how this command works. What the fuck does plus level - colors even refer to in this context? I can't really do much to fix it. This is the problem with being given the answer to a problem rather than going through the journey to find it. Fortunately, through my stumbling, I discovered that Infran Viewer also supports palette files, except in a different file format, this time displayed as decimal, but also incredibly easy to figure out and no hexadecimal encoding bullshit. With this, I was able to reconvert the outstanding files using an Infran Viewer command. However, this also didn't quite work as expected. All I wanted to do is simply specify a color in hex to find and a color in hex to change it to. Frustratingly, none of these programs can do a simple binary swap. Infran Viewer would take the palette file I gave it and try to guess the best color to switch it to, but this didn't always work as expected. For example, I may use a brown color, but the palette swap process would use a maroon color instead and disregard my original artistic intention. In some further reading online, I discovered that Infran Viewer had a fucking paint plugin the whole time, with a color replace option and everything, so I just used that. This is what happens when you get pissed off over dumb shit. Okay, now getting back on track. Windows has about 3 scripting languages, probably more, but the important ones to remember are BatchScript, which has been around since DOS, and is pretty primitive, but what I have used for the majority of this project, Visual Basic Script or VBS, and PowerShell that requires every fucking script to be signed before it can be executed. Fortunately, Windows has a simple command to disable this minor annoyance. That also applies to WinPE. That command is simply set-execution policy space unrestricted. Since in WinPE mode, we are by default logged in as local administrator, we are able to make this change without any UAC prompts. But I didn't know this at the time, and rather than fuck around with disabling it, opted for the unlock freedom of VBS, which was a mistake. This was the result of trying to figure out the regex pattern function in VBS. That ended with me randomly copying and pasting code off the internet, so I scrapped this in favor of a PowerShell version. Pretty much once I figured this out, I backported the code to VBS, and now both versions are functionally identical. But I still need to disable the execution policy if I want to use the PowerShell version. Which leads me to a side note. I don't want to be one of those blogs that just tells people, if a security feature is inconvenient, turn it off, and provide absolutely no disclaimer to the risks involved with having that feature disabled. In this context, disabling the execution policy is fine. We are in a VM that can't access the hard drive of the host machine, and the virtual machine doesn't even have a hard drive to save to, as it exists purely in memory. And the change we make will be session based, meaning that if I was to restart the virtual machine, it will revert back to what it was before. We are also already the local administrator by nature of WinPE, which means we can freely download random executables off the internet and run them with no issue. So having the execution policy enabled won't really make any difference to the security of the system. We also don't have an Explorer or spyware browser installed, which does limit the attack vector. So in this context it's fine, but if you were doing this on a real Windows PC, I will at least advise you to consider the security implications. Funny enough, you can write a VBS script or batch script to simply bypass the execution policy, making the security feature kinda pointless. I will tell you that I have seen this kind of hack used in production environments in the past, which always makes me scratch my head a little bit. Another funny thing to point out is the process of signing a script. It involves copying commands randomly off the internet. It is also not uncommon for a third-party driver pack to disable the execution policy. I'm looking at you, HP. So anyway, after I backported the tiles to mapdef script back to VBS, I could suddenly remember how to write in that language, which led me to want to troubleshoot that issue with the PowerShell script not outputting ASCII hexadecimal values via the outfile or redirect operator. I think outfile is just an alias for the redirect operator. But anyway, my plan was to create a wrapper in VBS and just parse the output of the PowerShell script to that. But halfway through, I decided to just write the color in hexadecimal to palette file script in VBS, and that worked without issue. In the end, this was completely unnecessary, but I found solace with the closure that came from having an answer, which is neat. And I can always reuse that script again if I need it in the future. Maybe for Duke Nukem 3D or Quake mods. Wait and see. With that ego boost, I set about resolving my quarrel with binary color replacement in ImageMagick. There is an entire section dedicated to color replacement, but it seems to rely on fuzzy logic. In either case, I still wanted to be able to pass back the output text file and recompile them as images. This script works, but I'll point out its inefficiencies. It works pixel by pixel, which isn't an issue when dealing with files this small, but it doesn't scale. To make the required changes to the file, I have it outputting the commands that need to be run line by line, so I can copy and paste them back into the command line. I learnt my lesson anyway, and that is to avoid palette files at all costs, but I enjoyed the challenge nonetheless. Now, finally, we can make a start on the project's assembler code, but first a bit of backstory. I started recording this video back in October of 2022, but a lot of the footage sat dormant on my PC as I got distracted with another code project, and I was asked to apply for a job, which took up a fair amount of my time for that month. After that, I also had to start retooling for my new job and training. I finally got some time over December, January to put together this video, but I haven't touched this project since October of 2022, so as much as I wanted to have had it done by now, it looks like there will be a part 2. Upon inspection of the assembler files, the first thing we will need to do is to conduct some refactoring. If you're like me, and you're fortunate enough to work in an enterprise environment, you may hopefully have access to enterprise tools. Enterprise tools that can define the architecture of our application, using UML or Unified Modeling Language, since I don't want to pay for Enterprise Architect, and it doesn't support assembly anyway. So what I am after is a class diagram to show the association between one or more classes, or files in this case. To put it more simply, since this code was generated from a template, I do not know what the fuck's going on inside it, so I need a printout of all the functions. In MASM32, functions are defined using the keyword proc, P-R-O-C, which is short for procedure. You can also declare prototypes for procedures using the keyword proto, P-R-O-T-O. Unlike C-style syntaxes, we don't need to define the data type for the procedure. Think of them as functions with no type or void. We can use a PowerShell command to quickly dump a list of procedures in a program. Get-child item-path, print working directory, .path, recursive, select the string pattern with the terms proc, P-R-O-C. So we can see about 9 procedures across 2 files. What are their prototypes? I simply change the word proc to proto and then rerun the PowerShell command. Here we can see all the prototypes are defined in the include file. Now where are our procedures being called from? We can see this by changing the word proto to invoke. Invoke automates the call interface to stack-based procedures, handles all pushing of parameters onto the stack, and cleans up the stack when a procedure returns. That was copied verbatim from the documentation, but think of it just like making a function call. That's funny. We had about 9 procedures local to our program, but not all of them are being used. Not all of these procedures make use of the invoke method. The hint is in the name, macro assembler. Those missing calls are using a macro. If we scan the source code in our IDE, we can see an include for the file macro.asm. I've got nothing against macros if they're well documented. Digging through the code, we see use of the term RV. What does this relate to? Further investigation shows FN, which we can only assume is short for function. If we conduct a string search for functions that we don't think are being used, we do in fact see it is being called by the RV macro. But also, what the hell is this crap? It seems we need to exclude exe files. Better yet, let's specify the file types to search, .asm and include .inc. For this, we will need to tweak our PowerShell command and add the include operator specifying the file type. Now, let's do a search on the usage of the RV and FN macros. Now we know where they are being used, but what do they actually do? After skimming through the documentation for MASM32, I gave up and started searching through the source code files, eventually finding the macro definition in the macros.asm file. Here we are able to confirm that the fn macro was just shorthand for invoke, whereas the rv macro is shorthand for return value. The return value stores the return value of the executed function in the EAX register. So to remove the fn macro, we simply replace all instances of it with invoke. And to remove the rv macro, we simply replace all instances of it with the word invoke followed by a move operation to retrieve the function return value from the EAX register and store it into a variable. MOV is shorthand for move byte or word, and its parameters are in destination and source order. In comparison to a copy or move command that I use every day, I would say this is in reverse order, as the copy command expects a source to be specified first and then a destination. Just something to keep in mind. EAX refers to the register. E is like a prefix to refer to 32-bit registers. A denotes the accumulator register, a short-term, intermediate storage of arithmetic and logic data in a computer central processing unit, CPU. I can only assume that the last character X in the register refers to extended, as other values include H for high and L for low, in reference to 16-bit registers. But I might be, and I probably am wrong, but I can't find anything on the internet that gives me a proper explanation. In either case, it is beyond the scope of this video. The main purpose for refactoring the code now is to assist with the compatibility when recompiling the application for a modern 64-bit Windows platform. This will come in later on in the project, probably in the form of a dedicated video. Future me injecting some information here. On the 20th of January 2023, the second version of the MASM 64-bit SDK was released. I have checked its contents and I can confirm that it does in fact include the RV and FN macros, although it does make it explicitly clear that this is a non-turnkey solution, so extra work is still required. So here I am continuing to refactor in this part of the video, stopping every so often to ensure the project still builds. It's the quickest way to find syntax errors. I have also sped this footage up because this part of the video is rather boring. So now we're going to figure out how we're going to make a grid to plot the tiles down onto, similar to what we saw in the image edit app earlier on in the video. The Windows API offers a convenient, although archaic, graphics library called GDI, or by its full name, the Microsoft Graphics Device Interface, GDI. Yes, there is an updated version of the library called GDI+. Not using it because it adds additional runtime dependencies. I am down a fucking rabbit hole. Theoretically, this app should work on an OS as old as Windows 95, the newest OS that my 386 can support. My 386 is in parts, by the way. You may have noticed also I set the .386 compiler directive in the code to make a 32-bit supported executable compatible with the CPU instruction set. Yes, the 64-bit version will use a different directive. So the first thing I wanted to make is a canvas. Just a simple container to keep all of our elements in. So this region of the window we can update independently. For this we will need to add a WM paint case to our main message handling loop. I am going to cheat a little bit and use a program called QEdit, short for quick edit. Under code, there is an option for create new subclass. I simply need to check the box and copy the code into our main program source code. As per the documentation, I started the painting operation by calling the begin paint function. I then decided to abstract this process a little bit and move it into its own procedure called WM paint. How creative. I defined the paint struct that will hold the information for our rect struct, which is basically a rectangle. Create compatible DC creates a memory device context, and create compatible bitmap creates a bitmap. This code is pretty much boilerplate, and you'll find plenty of not well documented examples of it within the MASM32 SDK. I created a bitmap handle here, the H bitmap, but didn't end up needing it. Since we are using the create solid brush function, I actually screwed up the color ref, so it defaulted to black, which is what I wanted anyway. I was ecstatic once I'd gotten this to work, so the next step was to try and figure out how we are going to draw the tiles on the screen so that we can manipulate them. Here I defined the tile's width and height at 8 pixels. Then I determined what position it should be drawn at by looking at the position of the toolbar, and I created a rectangle struct to hold a dib. So, in the GDI library there is a function called dib, or Device Independent Bitmaps. This is what showdib2 app that we used earlier on in this video was demonstrating. In order to use bitmaps in our application, we will first need to specify a handle and a device context, or DC, for the bitmap. This will allow us to define a back buffer. We can then fill out a bitmap info header and use the create dib section function to create a device independent bitmap dib section. We can then select that section and load it into the back buffer from the DC and use a function called bitblat to perform a bit block transfer of the color data that corresponds to each pixel in the rectangle. It's a square in this case because our block is only 8 by 8 pixels wide. To simplify this, we will encapsulate this code into a procedure so that it can be called recursively for each tile in the application. As I'm unoriginal, I referred to the procedure as tiledef2dib. This procedure is where I will define all of the data in a bitmap using a dword pointer and iterate through the EAX register to create an array of color ref values extracted from those text files from earlier. I basically copied and pasted the same code from the canvas from before, but this time using the rect struct that we defined earlier. I then called the tiledef2dib procedure to load our bitmap into memory. We should be seeing at least a pixel here, but it doesn't seem to be working. So in this footage I am trying to troubleshoot it. So there's the problem. Because I copied and pasted the code from before, I didn't update the bitblat function call to include the tile left and tile top values, and I was meant to subtract the top and the left, not move them. Okay, fuck yeah, now we have pixels on the screen. So for now, let's just hand import one of the bitmap files. I'll start with the second tile in the list, otherwise I would just end up with a blank screen. So this code is very hacky at the moment. I am good at pattern recognition, so I was able to determine that these pixels will only draw when the EDX register is incremented by a value of 3. I need to investigate why this is the case. I am pretty sure I figured it out at the time, but I didn't bother to document it because I am a fucking idiot. But I'm ecstatic now. I managed to load a tile into my program after a couple of days of piss farting around. I think that'll be it for part 1. Mostly because I'm fucking sick of editing this video. If your brain is like mine, and good at pattern recognition, you'll notice that the tile we drew in our program is around the wrong way from the program I first initially drew it in, so that's something that will need to be fixed in part 2. WinPE was actually a pleasant development platform to use. There was less distractions and no ads, recommended apps, or live feed bullshit. It also reminds me of earlier versions of Windows, like 3.1. It was only meant to be a gimmick or a challenge to see if it was a viable development platform, or use something in a way that it was never intended for the purposes of entertainment value. In part 2, we will look at loading these bitmap files recursively from our tilesdef file, as well as handling exceptions. We will also need to handle save and loading, as well as drawing on the canvas functions. I am also in the process of designing new UI elements, such as a drawing toolbox, and some dialogue that will hopefully allow me to redefine tile patterns from within the app. I do wish to issue a correction to this video, probably more of an addendum. I was saving it for part 2, but I know I'll get comments about it if I don't address it. Earlier on in this video, I mentioned containing WinPE in a virtual machine while showing footage of the Oracle VirtualBox website. While WinPE was running in a virtual machine, this whole time, the software that was used was actually Virtual Machine Manager and not Oracle VirtualBox. While it's possible to install Oracle VirtualBox on Trischool GNU Linux, it's recommended to use KVM instead, because Oracle VirtualBox is not fully Libre, and uses proprietary components for its compilation. It's a moot point seeing as WinPE is proprietary itself, but this video is more of an experiment to see if it was possible to develop software on a bare bones version of the Windows operating system. I also saw that there was entertainment value in it. I'm not actually a Linux user by choice. I rage quit with Windows in September 2022 and started using Linux with the plan to eventually transition to it fully. I can't escape Windows because it's used in my work environment, but I can at least lower my contact with it. The point that I'm trying to make about Tricycle GNU Linux is that I will frequently get asked, why don't I use Ubuntu or some other random distro? And I believe the fact is, if you're gonna go Linux, you either drink the Kool-Aid and go full Libre, or don't bother with it at all. I'm not really a technology-orientated person, but the fact is, out of the box, I didn't have to set much up, and there was also no spyware bullshit to turn off. I will acknowledge that I was in fact using Google when running search queries, but that's out of habit and probably won't be a thing in the future. I used a GTK program called Record My Desktop, and then cropped the video using an ffmpeg command. This is why you will sometimes see weird artifacts, and I left the static background in most of the time so that there was something to look at rather than just black bars. Here is a list of possible video subjects that might be covered as part of this video series in the future. This list is subject to change. The next video on this channel may not necessarily be part 2 of this series, still probably assembler related, so subscribe if you would like to see more. This video is also available on YouTube, or Odyssey depending on what platform you are coming from.